Inverting Schmitt-trigger comparator. Schmitt-trigger comparators are comparators that have positive feedback. So in the last video, we discussed open loop comparators. That is, there is no feedback from the input to the output in the open loop comparators. However, Schmitt-trigger comparators, they have a positive feedback. And again, there are two Schmitt-trigger comparators, inverting and non-inverting. So this is the inverting Schmitt-trigger comparator. And again, as name suggests, inverting means that your input is applied to the inverting input. And at the non-inverting input, there is a feedback that is going to the output, and you have a resistor connected between the feedback and the output, and the other between the feedback and the ground. So basically, your voltage at V positive right here is going to be using voltage division V out. So the voltage over here is going to be, which is this voltage right here, is going to be total voltage. Of course, remember, no current flows into the terminal, so these appear as in series, both R1 and R2. So the total voltage is going to be V out across the series resistor, and then R2 over R1 plus R2. R2 is the voltage, which is V positive, which is given right over here, right? Okay. The output oscillation is still going to be between such V set and negative V set. Okay, when output is V set, that is positive value of V set, V positive, the voltage over here is going to be what? We replace this V out by V set. So it's going to be V set R2 over R1 plus R2, and we call it positive threshold voltage VT, which is this. And when the output is going to be negative V set, of course, we're going to replace this V set by negative V set, and the output is going to be negative threshold voltage, which is discussed right over here. Okay. All right. Now, again, you have VD over here, right? Positive and negative. The difference between V positive and V negative, that is V input. So VD is your V threshold minus V input if your output is V set, right? And it is negative V threshold minus V input if your output is negative V set, right? So if your output is V set, that is your V positive is V threshold, which is equal to V set R2 over R1 plus R2. So you have this condition. Now, as long as this condition is greater than 0, output will remain at V set, because again, open loop gain is 200,000 and the output is going to be V set as long as VD is greater than 0. Now, how long VD is going to be greater than 0? As long as V input is less than VT, right? As long as V input is less than VT. So let's say you have V input here and you have V output here. So you have output high, V input is less than VT. Now let's say VT is here, positive VT is here. As long as it is less than VT, output will be high. But when input is gonna become, it will become equal and then eventually just greater than VT, what's going to happen? The output is just gonna down to negative VT, negative V ref. So right now output is V ref positive, and then it's gonna go to negative V ref, right? Now, as soon, or V saturation, I'm putting V ref, basically is V saturation. Now, as soon as the output is gonna become negative V saturation, what is going to happen? V positive is gonna become negative VT, right? V positive is gonna become negative VT, and this condition we will have right here. So now in this case, as long as this is less than 0, output will remain at negative V set. So how long is it is going to be less than 0 or negative in this case? As long as V input is greater than negative Vt, and negative Vt will be somewhere here, right here, negative Vt. As long as V input is greater than this quantity, the output is going to be less than 0, right? And the output, Vd is going to be less than 0, and the output is going to be negative V set. So for example, if you're increasing your voltage like this, you keep increasing, it's going to be 0. Now you start decreasing it, right? Decreasing it. So as long as it will not reach up to negative Vt, it will still remain at negative V set. Now when it will cross negative Vt, so you're going back now, when it will cross negative Vt, now V input become less than this negative Vt, and this quantity is gonna become greater than 0, that is Vd is gonna become greater than 0, and the output is going to jump back to V set right here, and it's gonna jump back to V set. And then if you keep decreasing it, of course Vd will be greater than 0, and then the output is gonna be V set. So this is kind of messy here. Look at this graph right here. So this is what we are discussing. So as long as your input is less than Vt, your output is V set, right? And then when it will become greater than Vt or just greater than Vt, the output is going to go down to negative V set. Now when the output will go down to negative V set, V positive is going to become negative Vt, as we discussed. So now when you start decreasing the voltage, so if you keep increasing the voltage, it will stay at negative V set. Now if you start decreasing the voltage, as long as it is greater than negative Vt, your Vd will still be less than 0, and the output will still be negative V set. But when it will become smaller than negative Vt, then Vd is just gonna become greater than 0, and the output is gonna jump to V set. This type of characteristic curve is called hysteresis loop, and if you took my power systems class, or if you're taking power systems class, then you know that we have the electromagnetic hysteresis loop that we discussed in power system class, that is related to the magnetism in a ferromagnetic or electromagnetic substance. This is the electrical hysteresis loop, that is a quality of your positive feedback comparator circuits. So this is how it is going to look like for, or these are the characteristic, basically our input output characteristic for inverting Schmitt-trigger comparator. Let's look at non-inverting Schmitt-trigger comparator. So the analysis is a little more intense as compared to the inverting one. That's why we are doing this one after the inverting one. Okay, so since it is non-inverting, the input is applied at the non-inverting input. Inverting input is grounded. Again, your Vd is here, positive and negative. And you have R input here, Ri, Rf, and the feedback from the positive input. Okay, again, there is no current over here, remember, I is 0. So these two resistors appear in series between V input and V output. So you can write down, of course, as we do the analysis, current here, I input is going to be the current IF. So this is I input current, and this is IF. So you can write down V input minus V positive. V positive, of course, is the voltage at the non-inverting input, over Ri is equal to V positive minus V naught over Rf. So we did the manipulation simplification, and you are going to get V positive equals this, V input Rf plus V output Ri over Ri plus Rf. So as long as this quantity is greater than 0, Vd will be greater than 0, and output will be V saturated. And when this quantity is going to become less than 0, then Vd is going to become less than 0, output is going to become negative V saturation. Okay, so now let's look at it. That with the assumption that the output, let's assume at the time that you're analyzing the circuit, the output is negative V set, right? The output is at the negative V set. So the transition is going to happen when V positive is going to become greater than 0. The transition from negative V set to positive V set is going to happen when V positive is going to become greater than 0, or in other words, Vd is going to become greater than 0. So when V positive become greater than 0 and V positive is equal to this quantity right here, that means V input Rf plus V output Ri is going to become greater than 0 at the time of transition from negative V set to positive V set. And from that, we calculate that V input has to be greater than R input over Rf times V set. Of course, V output, we are replacing V output by V set, because at the time of right now V output is negative V set. So sorry, we are replacing V output with negative V set. This is V output right here, right? Plus V out. So plus V out is replaced by negative V set. That's what the output is currently. So V input has to be greater than, from this relationship, V input has to be greater than R input over Rf times V set when V positive is going to become greater than 0 and the output is going to be transitioned from negative V set to positive V set. Or in other words, this we call V threshold right here. So V input greater than V threshold, the output is going to go from negative V set to positive V set. Okay. Now, when the output goes to positive V set, that is when V input become greater than V threshold, then if you want the transition to go back to negative V set, what you will have to do? Now remember, when the output goes to positive V set, you replace V out by positive V set. So V input Rf, positive V set Ri. So now when this, which is equal to V positive, when this will become less than 0, Vd is going to become less than 0 and the output is going to go back to negative V set. So this condition less than 0 means V input should be less than negative R input over Rf V set, and we call this condition to be negative Vt. So this is the input output curve. Input is on the x-axis, output is on the y-axis. So you have this negative V threshold and positive V threshold, right? Okay, so your input is negative Vt. So as long as input is less than V threshold, so we have this condition right now. As long as it is less than V threshold, it is at negative V set. But when it will become greater than V threshold, it's gonna go to positive V set. So when it will become greater than V threshold, then it's gonna jump to positive V set. Now you start reducing the value of the input. You're reducing the value of the input. As long as it is greater than negative V set, the output will still be positive V set, negative V threshold. The output will still be V set. And when it will become less than negative V threshold, according to this condition what we have right here, when it will become less than negative V threshold, the output jumps back to negative V set. So this is the hysteresis loop for non-inverting Schmitt-trigger, right? So this is the non-inverting Schmitt-trigger, and the other one was inverting Schmitt-trigger. So understand it properly, spend some time. It's not very hard. Just spend some time and, like I explained over here, understand it, how you're gonna create this hysteresis loop. It's quite possible that I will ask you, to show me, give you a circuit and then ask you to create the hysteresis loop of this and then create the output. And these examples are given to you. Inverting Schmitt-trigger comparator, 1 kHz triangular waveform, peak value positive negative 15. Okay, saturation we are assuming positive negative 15 as well. So when output is high, the threshold voltage, now first of all this is inverting Schmitt-trigger. So you calculate first what is the value of V positive over here, and the value of V positive is 10 volt right here. 10 volt, assuming that V set is 15 volt, right? So as long as the input voltage is less than 10 volt, VD is going to be positive and the output is going to be negative V saturation. And when it will become less than 10 volt, then VD is going to become negative and the output is going to go down to negative V set, and that's what you see over here. This is your input, green triangular waveform. So as long as it is less than 10 volt, the output is high, right? Because V positive is greater than the input, 10 volt. And when it will become greater than 10 volt, then V positive become less than V negative, or V non-inverting terminal voltage become less than inverting terminal voltage, and the output will go down to negative V saturation until over here, right? Because when it go down to negative V set, then what's gonna happen? V positive is gonna become negative 10 at that time, because the output is negative saturation. So V positive is gonna become negative 10. So again, as long as your input is greater than negative 10, VD will be less than 0 and the output will be negative V set. But when it will become less than negative V10, which is right here at this point, it is becoming less than negative V10. This is 10 volt, negative 10 volt, and then it goes down below 10 volt. Then as soon as this point is going to come, V positive is going to become greater than V negative, VD is going to become greater than 0, and it's going to jump back to V set. And when it will jump back to V set, of course, V positive again become 10 volt. So again, as long as V negative is less than 10 volt, output will be V set. When it will become greater than 10 volt at this point, then output is going to go back to negative V set and V positive become negative 10, and the cycle will keep on going. Alright, example 6.4 is non-inverting Schmitt-trigger. Now this is non-inverting Schmitt-trigger. R2 is 1K, R1 is 2K, and this is a triangular waveform with 10 volt and negative 10 volt waveform, and 1 millisecond time period or 1 kilohertz frequency. Okay, so the first thing we're gonna do is to calculate the threshold voltage. Again, threshold voltage is R2 over R1 V set, and saturation voltage is 15 volt or negative 15 volt. So the positive threshold voltage is 7.5 volt. So if the output is at negative V set, so initially observe, if the output is at negative V set, for the transition to V set, your input voltage has to be greater than 7.5 volt, greater than V threshold. So as soon as it's going to become greater than 7.5 volt, which is here, then the output is going to go to positive V set. As soon as output is going to go to positive V set, then the threshold voltage right here is going to become negative VT, that is negative 7.5 volt. So your VD is going to be negative 7.5 minus 0, right? So as long as, now to go back to, right, to go back to the okay, right now it's going to greater than 7. Okay, so let me go back. I think I lost my train of thought. So now as long as it is greater than so now the next transition is going to happen when V input is going to become less than negative 7.5 volt. V input is going to become less than negative V threshold. Then it's going to go back to the negative V saturation, right? That's what we discuss over here, right here. So the next transition to negative V set is going to happen when V input is going to be less than V threshold. So when V input is going to become less than negative 7.5 volt, it's going to go back to negative V set, and that was when that's going to happen right over here. At this point it becomes equal to negative 7.5, and as soon as it will cross this point, it's going to go to less than negative 7.5, and the output is going to go from positive V set to negative V set. And again, the next transition requires input voltage to be greater than 7.5 volt. So when the input voltage again become greater than 7.5 volt, output will transition from negative V set to positive V set, and this will keep on going. So again, understand it, maybe a little trickier, but not difficult.